our project completely rewrote files accidentally. We got so bad. All of our work, it was working beautifully. All of our test cases were passing. And even my project, I didn't even know.
I saw your code.
Okay? And it got completely rewritten.
Honestly, the only thing I cared about her was that I got above the and I was like, I'm done. We good.
Yeah, no, me and my partner were just.
And then we found each other. That's how we found each other. And then we were like, we should partner. And then it was a good time for all of us.
Do you work? I won't. I can't. Because like it's just like my schedule is so sporadic that I'd be like, hey, you want to meet at 2 a.m.? Like it just would never work.
Just in general, like we have is that like if I'm writing this function, I want to see the implementation of the other one. I don't that yet. I don't like what I don't want to really look at like what so like because I'm trying to get over what card you're thinking. I use a mountain so that I can sort the guard based on what you're holding. You walk today with a function, so I created a enough for it. And then I'm going to get to.
Oh, you just want to write your
Yeah,
right up.
that's that new stuff you write and
Is that short? You can do that. I also just it doesn't even
yeah, but that was getting pretty sorry. I think I was getting concentrate.
As long as that works.
Alright, I don't know if it works. I hope it does.
Because if it doesn't work, just write it yourself.
When is the interview?
Coming Friday.
It's fine. We need that. It's so much time. So don't realize it.
I studied.
Yeah, exactly. Okay, don't do that shit. That's not.
Yeah, I also killed myself. So don't do that. I remember the day before university, I just like took my tables at my work and you work on
Yeah, but if you had died, do you think it would have been worth it?
in my mind, I'd be like, yeah, this is totally
It's totally worth it. It's totally.
I mean, I would have slept it before I died.
That's all of your life just wasted.
I think I would know what my body is telling me.
No, but you can get hacked on a journal and crazy stuff happens.
Yeah, it's true.
It says that it is expectancy to be very helpful.
All right. There you go. It's Friday. We made it out again. Feels like getting to the end of the week every week gets harder as the semester goes on, and we're just barely halfway there. So we are in the middle of, or the beginning of, a new C4CS segment. So this one is all about developing. Today we're going to talk about build systems. So this resets the submission clock on your advanced homeworks. So you need to get one going here. This is, I think this is the last segment where if you haven't done any advanced yet, you can still get full credit by doing enough advanced, right? So if you haven't done one yet, please do. What else going on? Anything else administratively? Any good questions out there? Course structure? Good? Such a quiet Friday, crew.
You did 2 advanced homework prior to this, we have to do 2 more or 1?
Just 1 more for full credit, right? If you do 2 more, then you just get extra credit, so. All right, so I guess we'll just jump into this then. Build systems, that's our topic for today. Can somebody tell me what a build system is? Shoot. Make is a build system, right? Which, absolutely. So it's a set of instructions that helps you compile your program. It does some pretty nifty things here, right? So that gives us a quick answer to this second question, now that we've discovered that make is a build system, right? Because everyone's used make. You had to use it in 280. You have to use it in 281. So at this point, everybody's used a build system. So let's sort of have a look at how they work. And we'll start by looking at make, and then we'll talk about some other build systems. But I like to call make the grand binary of them all. That's pretty non-gender specific, right? It's the grand binary of them all. So the cool part about make was it just kind of came out of a need for how to make things work. So prior to make, if you had a large project and you were sort of distributing it by source, then you would have to also include a shell script. Say this is how you build it, or some sort of walkthrough for putting things together. So it started out as like a walkthrough for how to put things together, and say, well, there's still too many people messing that up. We'll just write a shell script that builds it. But then you're writing the whole thing. If you find this file, do that. And so the make language sort of came from that need of a nice way to put things together. And this is 1976 is when it was originally invented. And now we use GNU Make for the most part. However, it's still fairly old. I mean, it's ancient in terms of software. It's been around since '76, so there's not a whole lot of software that's still functioning 31 years ago, right? Is that 41 years ago? Yeah, bad math. 41 years ago. So you can think of a lot of things that have come along since then that have grown out of the make tradition. And so we'll see other build systems that very much lean on make. And there are other build systems that jump off and say, well, make was a good idea, but we're not going to start from there. We're going to create a build system from a different starting point. But they still essentially accomplish the same task as make. What else is good about it, right? It's automating our compiling and linking. That's nice. It's really cool for easily repeating long and complex commands. And the funny thing about it is we tend to, just because of the way we use it, we think of make as this tool for compiling C++ programs, right? You don't use it for much other than that. But make is a build system that is non-judgmental. It's made to put things together. So I had a professor friend of mine who used to run his whole course through make, right? And so he would say, well, I would he'd have all of his lecture slides available and he'd have all of his assignments, and when he wanted to release something, he would just add a command with make, because the make command would move a file to a location, it would make it visible to students. And so it was really building the course. So you can see now in the Dropbox, I can see, oh, there's this week's assignment. And make did that by moving it from a hidden directory to a public directory. And so you can use that command from make to automate whatever it is that you're trying to do, right? Easily repeat long or complex commands. So you figure it out once. You say, well, I want these files over there. And I just say make project 2. And it puts it over there. And so the student's version of make project 2 is quite different, right? They're writing something in C++, but as I mentioned, make doesn't really care what you're trying to make. It is originally set up in this sort of C tradition, so we'll see that there are some default rules. So we say, I need to know how to make a C file. Make assumes it knows what you mean. But once we get past a few different file extensions, then make just says, well, I don't have a default rule for that. If you want to have me do it, you're just going to have to tell me how to do it. So it's great because it can eliminate some unnecessary work in the sense that you write it once and you can use it over and over again. But you have to kind of come up with the work itself in the first place. So here's make syntax. in 2 lines or less. We really have a target, a list of 1 or more, 0 or more dependencies here. And then what's really hard to see is this white space is a tab character. If you've ever sort of copied a Makefile from a web page and then had it not work, you may have run into that situation where this came across as just spaces. Make is 40 years old and it's persnickety old, right? So if this is not a tab, these dependencies have to be separated by spaces, not commas, nothing else. If you don't do that right, make is just grumpy, right? So in this list of rules is really the things that we're going to do in response to the request for me to make some target. And that's what this target is. Make a target, you say something like make all. All is your target, and what it does is it goes into the Makefile then, looks for a target named all. It goes, make sure all those dependencies exist, are up to date, and then when that's the case, it does whatever these steps are. So for the most part, you can see all of our really simple Makefiles just have a compile command there. How many people here have automated some testing with make? Yeah, what'd you do? Okay, what'd you do? Make test files. Anybody else? I saw something over here, right? Nobody else use make for? Let's see if we can get to it today, right? Because make can run anything. You can say, I want to compile my project. Then, what do? Every time we do this, we compile the project, then we mash our up arrow key till we get to the time where we ran it with the right inputs, and then we run the inputs, and then what do? We copy all of the output, paste it up the diff checker, and then see if that worked out, right? It's heinous. Make can automate all of that for you because it does that. Over using a shell script? Well, the shell script can do more, obviously, right? Because it has access to a bunch of things in there. But it also requires you to know a little bit more, and you have to do a little bit more explicitly, right? So make, for instance, when we talk about these dependencies, it's pretty important about having dependencies up to date. And that's one of the things we get really often when our make files aren't up to snuff. You'll say make such, and it says, hey, that's already up to date, right? So it says there's a timestamp that's involved with something. And so make does that by default. If you're going to write a shell script, you'd have to say, well, if I ask to compile this and it looks like it's already been compiled, then let me check the timestamp here, check the timestamp there, multiple variables and stuff like that. So, I mean, we get a little bit of help out of it. We get a lot of help out of it in 280 and 281, but when you get into really large projects, like the Linux kernel, for instance, the Makefile that's there has like 300,000 rules inside of it, right? And that is a lot of work. And so trying to write a shell script that was going to keep track of all of those things, okay, it never stops, right? Yeah. Do not disturb on, yeah. I get disturbed all the time. All right, so does that answer that question? So shell script could do it, but make sort of simplifies because it's more focused on just that one thing, whereas shell scripts can do just about anything. So we'll have a look at that. So let's look at 3 Makefiles. The first one we've already had a little bit of work with, and that's this one from the folks in EECS 280, right? This is from the Winter 15 P2 project. And this is that directory where okay, hold on. Let's go back here. Oh, the demo. It's been the roughest semester for the demo in this course, I'm telling you what. You all saw that, right? It was like 30 seconds. I stopped to get a drink and then the keystrokes went in there. Never gonna work at this pace. That was me deleting LS. Attempting to delete LS. It's spinning farther and farther out of control here. Now it's non-responsive altogether. The whole machine is. No, it's back. All right. Okay. Well, where's that? What's that address for that EECS 280 directory? Remember that? Where's that thing at? I'm jumping out of here because it's just not working. No, nothing. We'll get there. I think. All right, well, let's get to the second Makefile then. And I can do this part on the board. Hopefully at some point I'll get a response back from my machine. It'll phone in from wherever the hell it went. Quit that. And I mean, shut it down. Get that thing restarted. Have open files. Okay, so when we look at how Make works, and I can't really display a lot going on here, I mentioned earlier that it has this concept of a timestamp involved with it and keeping things up to date. So what I get out of it is another directed graph. So here's a Makefile that we're gonna look at, and by look at, I mean you're gonna write. And so I'm gonna give you the graph of it and show you how to write some of the source code, and then you're gonna go to work, all right? So I'm trying to build this sentence, right? And a sentence is, of course, gonna rely on some things like a subject, a verb, and an object. Okay, so these are going to be files that end up in your directory when we get done. A file named sentence, file named subject, a file named verb, and a file named object. All right, so to really simplify things, we're gonna leave all of the C++ behind, and I'm going to say that I need some file here to create that file. So this is going to be your source code, and it's just going to be a shell script, right? So I'll call this create subject.sh. All right? There'll be a similar one here, create verb.sh. And of course, create object. Okay, so when I run this shell script, it's going to create a file named subject. That makes pretty good sense. So it would probably look something like this. Let's go shebang, bin, bash, echo, I into subject. Does that make sense? So that's your source code file. And you see that when I run that shell script, it generates a file named subject. And in the end, right, when you get to the sentence part, what you really need to do is say, I'd like to cat what's in subject, verb, and object. We'll put all that into sentence. Does that make sense? So this is how you create the sentence file. This is how you would create the subject file. And the sentence we're going to do is, I love C4CS. All right? So there's your sentence. I'll write that down over here. Gives us a subject, verb, object. Got it? So you've got to write some source code in these 3 source files here. And then I want the make file that I can just say make. And then I will be able to go look in this sentence file and have all that information there. To be sure, once I cat these files, it's not going to end up looking like this, right? Cat is going to put the files on separate lines, so it's going to be I love C4CS, but here's how you read it, how it comes out. We can work on that later. All right? Does that make sense? Is there any questions on what I'm asking you to do here? Make file, 3 source files, 4 source files? We need 4 source files, right? Because how do we make sentence unless we do that, right? So you can put this in a source file as well. However, you could do it without a source file. I suppose you could go that route as well. But let's see what we get, all right? You work on that. Meanwhile, I'm going to see if I can make anything up here work, all right? So take a few minutes, go for it.
Yes, so we got a day in the class then. Here's saying, right, 11:32 a.m. There you go. I got it. Right now, no one going through this line. Yeah, that's what I did on the van. I was like, you know, it's great. It's 21.2. I'll always say, I'll do it. I know.
How'd we do? How are we doing? We still got more work to do. Almost done. Got it. Stuck. Still see heads down, so it looks like work is happening. Work is happening. So many notifications, it's unbelievable.
Like, do this during the show. I don't
All right, try it again. What do we think? Is it good? How do we do? What are 50% done? 70% done? At least 50% done, I guess I should say. At least 75% done? Done? We done? Got a couple of dones in there. All right, well, we've only got so much time, so I'm going to dig into it myself, and you can sort of watch as I go along, and you can get into it as well. So we already had to get started here. So I talked about that file over there, my subject file. So I'm just going to create subject.sh. All right. Bin bash, and I said all I had to do was echo I into subject. Good enough. So there's my first source code file, and to make this work out, I'm just going to copy that over to create object as well. And that's going to go into create verb.sh. All right, now let's edit those things. That one is object. C4CS. This one should be subject, that's good. This one should be verb. All right. There they are. There's object, subject, and verb, right? In alphabetical order. That's the file, that's the file, that's the file. You saw I just catted them all out. So it's really hard to figure out where things going between that. Another way that you can do this, especially with short files, if I just said head of all of those things, then it sort of gives me, hey, look, this is in create object, that's its content space. This is in create subject, content space, and so on. So it's another way to sort of tool around there. didn't make verb into love. Good call. There we go. So let's VI create subject, verb, C word, verb. Great catch. So verb.sh, subject.sh, object.sh, and we're good, right? So now I've got my source code files, but none of them run, right? In terms of shell scripts, I should probably change mode on them, right? Change mode so that they're executable. So change mode, let's just say +X on all of my create files. Now that list looks like things that are gonna run. So I've got my source code, which also doubles as executable code. We find some weird stuff that go on there if we don't do that, but we're good there. All right? So far, so good. So what does Makefile look like? Makefile, and Makefile has to start with the word, it has to be named Makefile unless you dictate it something else. By default, it just shows up as Makefile, capital M Makefile, must be that. Get over it if you don't like it. So I'm gonna say sentence, and it looks like that depends on what? We said that it depends on subject, object, and verb. Just like that. So let's try it just like that, and then type make. All right, so what it's telling me here is I just typed make, and one of the defaults of make is it looks through your make file until it finds the first rule, or the first target. If I say just make and don't give it a target, it looks through the file till it finds the first target and decides to make that one. So that wasn't too difficult in my make file since it was one line, one target. It says, well, we'll try to make sentence, and to make sentence, I can't do that until this dependency is satisfied. I need a subject. But I can't make the target subject that's needed by sentence. Okay, let's edit the make file then and add one of those things. Right? I can come down here and say that subject subject depends on what? Well, it runs on create subject.sh. So there's my way that I can build that. Now I know how to build subject. If I try make again, it's great. So it got past that problem, right? The problem of subject not existing. So that's good. It got to the next problem. So in terms of what we had here in the graph, it kind of looked like, where'd my marker go? Go. This one any good? Yeah. All right, so I started out and I said that I wanted sentence, and sentence depended on subject, object, and verb. So that was what I first started with. When I had a one-liner make file, this is what my graph looked like. A sentence which depends on all of these three things. So when I said make sentence, it said that'll be great as long as this dependency is satisfied. Well, since there's no way to build this by default, make just bailed out. I don't know how to build subject. There's no default rules because there's a lot of default rules that are hidden. So without them, it says I can't do that. So now we're saying that all you need to do for subject to build that is to sort of run, create, subject. .sh, right? So that's great. I can copy those things along and could have done this faster. All right, that's good, right? Now I should get rid of all of those problems. It makes good. We're good? Well, let's see what we got. Well, I've got my 3 executables, create, subject, object, and verb. I've got Makefile, and I have object, verb, and subject, but I have no sentence. What happened to sentence? Any idea? Let's have a look at the file. What happened to sentence? Right, I have dependencies. I need these things to be built, but I didn't tell it what to do once they were built. And since there's still no sort of default way to get to that, it doesn't know how to do it, right? So this is where I say that Make has a lot of defaults. If this was a C or C++ project, if I had a file in my directory named sentence.cpp, and I said make sentence, it would say, oh, you probably want me to GCC that sentence.cpp file and call it sentence. I can do that for you. So Make does a lot of things by default. But in this case, this is just, you know, a non-extension file. It doesn't know what I want, so it bails out. So to get that done, I said I needed to do something, and from there I said we should run that create sentence thing, which I have not created yet. So we will get to that. Create sentence.sh. All right? So that's there. And if I edit that file, can't type today. Echo, nope, this is what I said. Cat, subject, object, verb, into sentence. Change. All right, now I'm ready to go again. So I should be able to type make, and since my Makefile has something that it included, we can see what's actually being executed. Make sort of echoes what it's doing for you. So that time when I typed make, it ran create sentence. I'm happy now that I see a create sentence executable, and I also have a sentence file. So if I want to look at that, I can say what's in sentence, and oh, it works after a fashion, right? I've got some spelling errors there. So we can go fix that. It's not spelling errors, it's just a grammar error. So I can fix that because I said subject, object, verb. I should have said subject, verb, object, right? Okay, so we'll then type, no, not that one. When I'm create sentence. All right. Subject, verb, object. Make, and watch the magic happen. Why no magic? I just changed create sentence. What's that? None of the dependencies of sentence were changed. Right? So it looks like my dependencies are just those other build artifacts, like the builds from my small word generator. So those artifacts were needed, but it turns out that sentence actually has its own source file. We can see it. That's what we actually run there. So to make that happen, I do need to say create sentence.sh here. Does that make sense? now depends on these sort of pre-built things, these other targets. The sentence target depends on these other targets, which in turn depend on their own source files. Make is wonderfully recursive. These dependencies depend on other things that depend on other things. And so all you have to do is just one command, and it keeps going through the recursion level of what depends on something else, depends on something else, depends on something else, until I get that, and it works. So if I say now, sentence depends on those other words being created for me, I also need sort of the grammar that glues it all together. So I just edited create sentence. I was hoping that it worked, right? So now as I type make, we can see that just create sentence runs. And if I go look at my sentence, life is good, right? Excellent. Let's then change our subject. We love it, right? I call make again, I've got that same problem. This is not surprising, is it? I just edited my create subject file, but it thinks that sentence is up to date. Let's do a long listing and see what it tells us. So here's where our graph is important. This graph is a temporal graph as well as being a dependency graph. So as I look at it, this depends on that and everything in this level. This graph is now incomplete. We realize that we left something out here, right? Sentence also depends on create sentence .sh. Good. So this graph being temporal says when I tried to make sentence thought it was up to date because sentence depended on create sentence. And if I look at it, it's easy to see, right? Sentence is up to date because it is younger than everything it depends on, right? 1153 comes after 1152, its source code. It comes after the other build objects, object at 48, subject at 46, and verb at 48 as well. So that's what the up to date has to do with. It's saying when you ask me to build this, it looks like I'm newer than anything that I was built from, so you can't really need to build anything. And that's really powerful when I talked about the Linux kernel with 300,000 rules. You can think of how many files that also works with. And if you want to build a project, you don't want to recompile a million files when you've only edited one, right? So the temporal nature of this graph is very important because it saves you work and saves you time. So I can fix that just by using touch, right? So if I say touch object, now if I try to make it, it's going to say I have to run create sentence again, right? Because object, when I touched it, got its timestamp to right now, something like 1156. So when I touched object, it was at 56. And then when I said, should I make sentence again, it says, well, sentence depends on object, but object is newer than sentence, so then we have to remake sentence. So it's going to do the commands for sentence, or the rules as they are in sort of the normal syntax, right? So it called create sentence there just to do that, right? The other problem I have is I don't have enough dependencies in there, so let's go back here and say that why wouldn't all of these sort of depend on their source code, right? So to pull that, I'm going to say yank, yank, undo, right? And that looks more like what I'm expecting, right? Now if I make a change to the source that creates verb, create verb gets run. which in turn makes verb be younger or newer or more up to date than create verb. So the next time I say make verb, it looks at its source file and says, well, I'm newer than that. I must have been built from that. So I don't have to do anything for building verb. And that, as I mentioned, because of the recursive nature of these dependencies, says I don't have to remake sentence in that way. So here we go. Now everything is up to date, I think. Oh, what happened there? I had made some edits to subject. Remember, I changed subject from I to we. So subject, the file, was out of date as being older than its source. Once this gets updated, now sentence is out of date because it's older than its dependencies, and we had to do that. So this is really what I'm talking about in terms of the temporal nature and getting this graph going, these dependencies. And so you can think about when you write something in C++, that's one of the things that I see most often is we give the 281 Makefile out. We say, here's the section at the bottom where you have to include your own dependencies. And everybody's like, I don't know how to write my own dependencies. For one, your .o files, because those get compiled from your .cpp files, they definitely depend on their .cpp files. That's an easy one. That one is actually a default rule that's written. It's not a default rule. It is a default rule, but it's an explicit rule that's in that Makefile as well. It says a .o file depends on a .cpp file. So you can have that. But then you say, well, if that's there, why would I ever need to add any dependencies? And we see it really strong in Project 2 when we hand out these priority queue .h files, and you have to use a .h file to build your actual executable. So in the end, you say something like, my project depends on my project source file plus all of these pq.h files. So when I make a change to my code, it needs to be updated. When I make a change to the priority queues, it still needs to be updated. And depending on the semester, this may or not actually apply to you. Some semesters we make people use the PQs in their actual solution. I think this semester we're just using standard library. But that's the kind of what you're trying to do there. So you can say I've got my own custom class, right? So my own custom class might show up as some .cpp file and some .hpp file. So if that's what's going on in my class, and then my solution uses that, you can look inside your solution, right? So my solution is really just something that's some .cpp file, right? That's where all the code happens. In there, I've got my solution include this HPP file. Because the HPP file, the header file, is the interface between this code and that code, right? This CPP file is the implementation, and as long as the interface doesn't change, how it gets implemented over here is unimportant over there. So my solution doesn't need to be rebuilt if I just rebuild my class here, because that implementation, so if I just edit my CPP file, right? It needs to be rebuilt when this interface changes. That's when the objects can't be linked together again, right? Because as I compile, this goes to my class.o, and this goes to my solution.o, right? So any edits that I make in CPP will invalidate my .o file. So I can remake that. But if I change the way it works, when I go to make my executable, the linker says, let's link the things in this object file to the things in that object file. And so if they are new, the linker is going to make a new executable, but without the need to recompile your solution. Right? It's only when I make edits in this header file, which is the interface, that says, hey, there's going to be not only possible changes in the implementation, but changes in the way that we speak to that implementation, and this thing needs to know about it. So that's some small compilation stuff there, but you can see how it moves forward with this dependency graph of .o files depend on their .hpp files and .cpp files and so on. Yeah, make isn't that smart, right? It's just looking at timestamps, right? So yeah, if I do edit this and then I edit that, I mean, essentially it's saying I'm in charge of building these things. If you're gonna mess around in them on your own, sort of doing your own version of building, I can't be responsible for that. So I mean, we can edit sentence because this is just a text file. But if I was building executables, I wouldn't think of sort of going into an executable and editing that. So make is saying, I'm assuming that I'm in charge of building. If you're gonna do anything on your own in terms of building, then I can't be helpful to you. So. Oh, come back, don't go to sleep. All right, is that pretty good? So now that we've got this thing back up, I think I can have a look at, well, we said we were gonna check one thing out. So let's go back to trying to see if I can test something. So it would be really nice to know when I ran some of my code if it worked. So let's just see if we can't build a tester for verb, right? So I'm gonna do that here. Just truck down to the bottom and say, this new target is called test verb, right? And of course, if verb doesn't exist, I can't very well test it. So I'm gonna say that verb really depends on, or test verb depends on verb being there. All right, verb in this case is something simple, it's just love, and I'm gonna say, let's diff what I get when that runs with what I expect. And one way I can do this, which is cheap and dirty, is to just say echo what I expect and pipe that into diff of verb and dash, right? So diff generally expects 2 files. I'm saying the second file is gonna be from standard input. So as I echo love, it just puts love out there, and then it pipes it as the input to diff verb, and we've got it. So let's see how this goes. Let's try make test verb. And it echoed what was in that command, which I don't know if that really works. How do I know if that works? Well, I know it works when it doesn't work, right? When I break things. So let's change that. So go here to that and say S. I loves C for CS, right? Now, when I run make test verb, it says, look, your recipe for the target test verb failed because on the left-hand side in verb, I got love, and on the right-hand side, which was pumped in from there, I got loves. So I know that that test failed, right? And this is a simple way to do it because I can just do it in one line with echo. But if you have your expected output in some file, you could just as easily have said, you know, diff expected output with received output. And it would tell you right away if that worked. And if I made some edits, so let's see if I edit create verb, right? Let's do that. So now I've edited create verb. And if I try testing verb again, it says, well, I can't test verb without actually creating it because it's already out of date. So the first thing it does is it looks at that dependency and says, test verb relies on verb relies on create verb, and it's older than its source, So then I'm going to recompile verb and then run verb and see if it actually matches up there, right? So that's kind of a junky way to look at all of this. So I can go back and VI the Makefile and say, I'm going to go to this tester and just insert an @ sign, right? That tells Make, don't echo your command. So now this would just kind of run silently, right? Then I can say here, echo all tests passed. All right? So, let's run it again. Look at that. All my tests passed. If one of them didn't pass, right? So now I just edited that file. I used the stream editor. I changed loves back to love in create verb. Now when I run make test verb, it has to recompile. It does. And I see that love doesn't match loves. Love doesn't match loves. And the recipe now failed. And I don't get to my nice message that says, hey, all tests pass. Pretty slick, huh? So you can automate this as deep as you like, right? As deep as you like here, you see I first, in test verb, I ran this command, sort of the diff command, and then the next one was, let's give me a message about it. If I wanted to, I could run a bunch of commands, run a bunch of diffs, and then the sort of all tests pass makes a little bit more sense because there's more than one test. In this case, there's only one test, but you get the idea, right? And you saw what I did here is I inserted this @ sign so that make didn't echo it. Because even without the @ sign here, make would say, hey, echo all tests passed, and then it would put out all tests pass. So you would get both of them. Does that make sense? Because it echoes whatever the command is, even if the command is an echo. All right, so we now have a little bit of time to go look at this 280 Makefile and see kind of, we'll be a little bit more informed because we're better at this now, right? Any questions on this? Anything that you might see that you can add to this? You can add anything to it. One of the things that's kind of interesting that I haven't talked about is, I'm talking about these targets, and I say make something, and I say, well, that works because it can check the timestamp of this versus the timestamp of that. But what about test verb? How does it check the timestamp of test verb? Because test verb doesn't actually exist in my file, in my directory, right? Test verb isn't there. So this is what make likes to refer to as a phony rule, right? A phony rule that doesn't build an object, right? So when the rule is phony, make doesn't try to see if it's newer or older than its source. It just does it, right? So in this case, it does look for it. It says, is test verb newer than verb? Well, I can't find it. I might as well do the work. You can simplify make's task here by doing something down here at the bottom like dot phony of test verb. So now it says when you type test verb, there is no file named test verb to compare to the timestamp on verb. Just do the work. So if you see a phony line in there, it's for things like when you type make all. If you have a real Makefile that has make all in it, there's no file named all that comes out. Or when you type make clean, for that matter, right? Make clean doesn't make a file named clean. How would our make clean look over here? We could say clean doesn't depend on anything. But I do want to remove subject, object, and verb, and sentence. Leave my source code alone. And that's a phony rule, so I'm just going to say that it should look like that. Sound good? Let's give it a test. make clean. Okay, it worked, right? I think it did. Yeah. All right. So now we'll peek at a couple other Makefiles. We said yeah, shoot. Phony says that when I give you a target, right, I said make clean, the target is clean. By default, make says I'm going to go see if that clean file is newer than the things it depends on. But when I'm saying it's a phony, saying that rule doesn't generate an object. So I'm not going to be able to find any file in my directory named clean. So it's important in really strange cases where you might actually have some object that's the same name as one of your targets. And you want to make sure that that thing actually works or doesn't work. So that's just what you'll see there. That's what it means when you see something. It usually is at the bottom. You'll see phony, and there it is.
So when we're doing echo for the test group, why do we never see the first one, but we sometimes see the second one? Because I thought you said it's the outside it didn't actually echo it. So how do we ever see the test?
So what make does is when I type this one, it'll say echo create sentence.sh because that's how it built it, right? So when it hits this line without the at, it echoes echo loves this thing, right? So when I hide it, nothing shows up. And same thing here, I wanted to just say all tests pass. So I put it in an echo. But without this, make is going to echo the command and then do it. So it would be like, echo all tests passed, next line, all tests pass. And that's a little redundant and silly looking. So that's why I put this one on there to hide that. And one of the ways that this works, you saw that as soon as something failed, make just bailed out, right? When I was trying to build subject earlier, subject didn't exist. It just said, hey, I can't do this, I'm stopping. When I'm running this test thing, if this doesn't match up, right? How do we know that it doesn't match up? It's return codes. That's why we always have main return 0. That lets the system know that we exited appropriately. So when diff looks at two files and they're exactly the same, it returns 0. And make says, hey, I was looking for diff to return 0, I can go on and move forward. But when there's a difference, make returns something that's non-zero. Or sorry, diff returns something that's non-zero. So then make says, well, one of my commands returns something non-zero. We broke along the way, don't do anything after this.
Can we edit what make does when it gets a non-zero?
When it gets a non-zero, absolutely, right? So we've got make test verb, right? And it fails. So let's get in there and I'm going to, I almost never do these together, but I think if I insert a minus sign there, it says, don't care about what that return value is. Right? So now when it hit the fact that my diff didn't come out clean, that was an error, but the minus sign that I put in there just said ignore the fact that it exited with error and continue with your list of things to do. Right? So if I tail Makefile, you can see right there. So test verb, this minus sign said, even if this fails, continue to do your work. So then all tests pass is really a lie, right? Because I didn't pass this test. The test verb failed, but I still keep going. So yes, you can change how make responds.
I was asking, you know when diff failed, it says make file, recipe for target failed.
Mm-hmm.
Is there a way to tell it not to output that error?
Sure, you could just take that error and you could send your 2 to dev null in the command, right? You mean like that? So here's the command. The 2 is the file descriptor, and this is going to redirect any errors straight to dev null, which is our ultimate sync. We can just write there forever. So haven't tried this one before? Let's give it a run.
Sorry, what did
didn't work. What's that? The 2 sends standard error over, right? 1 is standard in, standard out. Yep. So without the 2, it's the same as, and that one didn't work, so, because it's not coming out the error channel, it's actually coming out the standard out channel. So this, the 1 redirect, is the same as that. There's 0, 1, and 2, right? 0 is standard input, 1 is standard output, 2 is standard error. So there we see makes output. To make make shut up, I have to do that something in there, right? But you see how I took the output of the diff and made that go away. That's just gone. But yeah, I think it's, I don't know if you can make that thing not make noise, because that's an actual make thing. I'd imagine there's a way to. There's so much in make. Make's actually a fully Turing complete language. So anything that could be programmed in make. I wouldn't want to, but it's possible. All right, so we got a couple of minutes. Let's look at this EECS make file from 280. And this @ sign down here means I've reached the end of my file. So that's not in there. But what we see here is 3 targets. I've got all up front, and that's pretty common, so that your make all is the same as make a lot of times. So a lot of times you'll see that the first rule is the all rule, and that's cool because that's possible because of the recursive nature. It's not like that filter test rule has to be defined before I have the all rule. It just says I'll find that later in the file. So all depends on filter test, simple test, tree insert test, and the P2 tests. So you say, well, how do I make filter test? Filter test gets made like this. It needs all of these things, right? Which is some source, 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 source. And when I've got it, use this very large compile command. So this is a great thing for Makefiles too, because I don't forget something, and I don't have to type this ridiculously long thing out, which isn't that difficult when I'm in one session. I just mash the up button and get to it. But what happens when I come back the next day? Do I remember how I compiled that exactly the right way? Maybe, maybe not. Thank you, make, right? So here it is. To make filter tests, I have to do that. To make simple tests, I have to do that. I guess tree insert tests shows up down below here, doesn't it? Yeah. Yeah, there it is. There's tree insert tests, P2 tests. I've got to make tar, I've got to make clean. So this Makefile doesn't have any phonies in it. It should, right? Because tar is phony. We don't actually create a file named tar. Clean is phony. There's no file named clean, and all is also phony. So I would probably want to include those in mine. These rules kind of look like the rules that we've looked at already. So the only one that's a little bit more interesting than what we've seen is here at the top, right? Here, if I said make test, it's going to build all of those test files, but then it's also going to run some stuff, right? It runs simple test and dumps it into simple test out. Then it does a diff on simple test out with simple test.out.correct, which is kind of what would be really helpful when we're running our own things. It also runs filter test, which doesn't have a stored output component. Same thing with these two things, and .p2 test as well. And there we've got our echo of all tests passed. So there's an example of a make target with multiple rules. And it's nice to see what's going on. So these things aren't hidden with our ats, right? Say, well, I want to know what's going on there. This is not so necessary to see. We just want to see that all tests pass. Got any other make ideas, make questions?
If you like just didn't have echo there and just wrote all tests pass,
Mm-hmm.
then would not echo.
Well, no, it's going to give, it's because it's echoing what it's going to do, and then it does it.
So why it tries to do it.
So it would be really just saying all tests pass to the shell, and the shell would be like, I don't know what this all command that you're talking about is. Or maybe I do, and I didn't want that to happen. So yeah, it's really just passing commands on. So if you didn't have echo there, it wouldn't say that, but it would still throw that up there, and then you would have the command line error of, I don't know what all does.
If we do something in Make where, for instance, test uses filter, test dependencies filter test, and then in filter test we have simple test as a dependency as well, but we also call simple test. Would that cause an error?
You're trying to get like some circular dependencies there?
Yeah.
I'm trying to figure out how to set that up. So one depends on another, depends on another, depends on the first. I don't know about that one. I'll have to try that. I'm low on minutes, so I'm not going to try it here, but that's a good plan. I'll see what's going on there. Yeah, that's it. Yeah. Make all says, I can't do all, because, you know, we saw how when we first put a rule up there with no actual, so we put a target up there with no rules, it still tried to find those things, right? When we first did sentence, just depended on subject, object, and verb. It says I'm going to try sentence, but subject doesn't work, or I can't find subject. Let's build subject, right? So there was nothing to do for it. Once we got subject, object, and verb working, sentence still didn't do anything. So yeah, all doesn't do anything, right? It just says, I need filter test. And filter test says, well, in order to get filter test, I need these source codes, and then I'm going to compile like this. So yes, to satisfy the dependency of all on filter test, it builds filter test. But once all of those things are built, there's nothing to do. You could put there all things built if you wanted to, or, you know, it's sort of as a command, but there's no need for it.
So if I just type make, will it always go to all, or just the first one?
It's going to go to the first one always, right? And it's just a convention to put make all as the first one, because that's kind of what people generally think of as make all and make are the same kind of thing. Yep. All right. We got a couple minutes. I'm going to jump into this 281 Makefile that I made. So you may have seen it. You may have looked past some of the stuff that you didn't want to know about. And there's some stuff in there that I don't want to know about. So let's do a wget of, not that, GitLab. (281) Makefile slash master Makefile. All right. All right, so this is more make, right? We looked at just sort of the basics, which are target, dependencies, rules. But it turns out, as I mentioned, make is a fully Turing complete language. So I can do variables, I can do for loops, I can do if statements, and all sort of things, right? Here's comments, anything that's got an octothorpe, comments from there to the end of the line. So this is the EECS 281 Makefile. We've got a couple of variables that we set up here, path, load library path, load run path. And all that is just assigning to this value there. So we'll see as we move through here, there's some weird assignments, right? So here's executable with equals executable. And those of you that are sharp might say, why this and that, right? Why is this setting it equal and this also setting it equal? I think there's 3 or 4 different ways to set things in make, right? It depends on when you want them to be set. So in this case, I'm saying set this, but look at that path. I can't really set this sort of when I write the file, because path, being an environment variable, might be different, right? So this doesn't run until, this assignment doesn't happen until it's actually being done. Whereas this assignment can happen sort of at source code editing time. So you can think of this as sort of happening at compile time, and this is not happening until execution time. So there's some variables here. You see some substitutions. So I named executable as, right now it's executable. And then there's another one that's debug that's called it's executable underscore debug in this case. So it just does the substitution there. So I've got the ability to do substitutions. Here's where the compiler comes from. You see a function here. This is the wildcard function. So this looks in my directory and says my test sources, and everything in Make is just lists of text or text and text or test. Sorry, it's text or a list of text. So test sources, get that from calling this wildcard function and find anything that matches the pattern test anything.cpp, and then assign that list of file names to this variable named test sources. So that's what's going on in that line there. The names of my executables, right? These are going to be called tests. And here's another make substitution. Say takes test sources and turn anything that was .cpp at the end into just nothing. So if I had a file named testmyobject.cpp, it would show up in test sources. Meanwhile, testmyobject would end up here in tests without the .cpp. So now I have a list of file names that I'm looking for in terms of source, and I also have a list of file names that I'm looking for in terms of executables. So you can see how some of this automation is just already happening, because I can say make tests. It says, well, I have a list of all of the executable names because they're based on CPP names. So my tests, the way this one is built, anything that starts with test has to have its own main in it. We got our link going up. Nicely done there. Right, so we cruise on through there, the same sort of thing. Here we see an or, right? If this shows up as false or an empty string, then do that. What other things are in this one that are interesting? Here's where, I guess, make all comes in place, right? Where is make all? Nice. That's cool. You can try right there. Yeah. It's closer to them. So you can see here that sort of these commands are kind of stacked. Release sort of does an assignment. It takes this variable and adds some flags to it. Debug does the same sort of thing. It takes and adds some flags to a variable. See some cool stuff going on in there. There's all. It's not really the highest target anymore, but you can see how make all works. Make all just depends on executable. And executable just depends on that list of objects. And objects just depends on a list of those sources. So if there was a .cpp file in the directory, it says there's a .o file that should be dependent upon that. Here's an if statement. A bunch of stuff going on in there. So this is make. This is how build systems work. We got a lot in there. All right, I'm done. Let's get some food.
it's a demo, and I'm like, I know developers are frustrated.